In this video, we're going to look at determining the Kb, so the identity of an unknown base, if we know its pH and its concentration. So a typical question would be, what is the Kb of a weak base if a 0.1 molar solution has a pH of 10.43? So for this, we're going to use a generic base. We're just going to say A minus, so just some generic anion, plus water, forms its conjugate acid HA, plus OH minus. So that's our generic base formula. We're going to use our ice table, ICE, and we know that the initial concentration of this base is 0.10 molar. You don't really need to write the molar, so 0.10. We never include water in an ice table for acids and bases, and we always start with 0 concentration of our acid and 0 of our hydroxide. Now, normally we would fill in X's here, but we're actually able to solve for this equilibrium concentration of hydroxide because we have a pH. So we're going to take our pH, we're going to turn it into POH, and then turn that into the concentration of hydroxide at equilibrium. So POH is going to equal 14 minus 10.43, which equals 3.57. And the concentration of hydroxide is going to equal 10 to the minus POH, so 10 to the minus 3.57, which is 2.69 times 10 to the negative 4. Now I'm keeping an extra sig dig in here when I write my answer down, but technically we should only have 2 significant digits. So that's our equilibrium concentration of hydroxide, 2.7 times 10 to the negative 4. HA is going to be the same concentration. And so that's also our change. Because we started with 0, our change is going to be equal to our equilibrium concentrations. And that's true as well for HA. So net minus 2.7 times 10 to the negative 4. And when we do that math, we end up with basically no change in our concentration here. So 0.1, and that's rounded up. So I'm going to keep the actual number in my calculator, which is 0.0997. Okay, so now you can figure out Kb by writing our expression. So it's always HA, so the conjugate acid times hydroxide divided by A minus. And that's going to equal 2.7 times 10 to the negative 4 squared, because there's same value twice, and then divided by 0.10. And that gives us a value of 7.3 times 10 to the negative 7. So that, that is our Kb value. We could then use that to identify what base it is by finding the Ka, but normally this is where we'll stop the question.